When I was getting ready for English, I got carried out. I found an interesting article and a lot of material for it. And it would be difficult to tell it all at once, and it would not be so interesting to listen to. So I decided to record a video about it. That's what I got.
I'm glad to welcome everyone. My name is Vladimir, and I'm a third-year student of the Physics Faculty of the Moscow State University, Department of Mathematical Modeling and Computer Science. I specialize in statistical method and data analysis. Today I want to talk about Naïve Bayes Classification algorithm, and structure of my speech is as follows.
General concepts of Bayes theorem, Naïve Bayes algorithm, NBA, mathematical introduction of the NBA, a simple example of the Naïve Bayes classification, paper Naïve Bayes for text classification with unbalanced classes, application of multinomial Naïve Bayes in practice, conclusion. General concepts of Bayes theorem.
Bayes theorem is a simple mathematical formula used to calculate conditional probabilities. You all know her, but let's remember what it looks like. It shows how often event A occurs when event B, and it has a second name, a posterior probability. At the same time, we need to know the first. How often does event B occurs when every event A occurs? The second, what is probability that A does not depend on other events? And the third, what is probability that B does not depend on other events?
Naïve Bayes algorithm, NBA.
The simplest solution usually turns out the most effective, and in this essence, an example of Naïve Bayes algorithm is indicative. Despite the great successes in machine learning in recent years, the Naïve Bayes algorithm remains not only one of the simplest, but also one of the fastest and accurate. It is successfully work with many tasks, but it work especially well with natural language processing tasks. The Naïve Bayes algorithm is a probabilistic machine learning algorithm based on the application of Bayes theorem with assumption of feature independence, and it's very important. Put simply, the NPA assumes the presence of any attribute in the class is not related to other attribute. For the example, a fruit can be considered an apple if it's green, round, and its diameter is about 8 centimeters. Even if these figures depend on each other, in any cases they make an independent contribution to the probability if this fruit is an apple. That's why the algorithm is called naive. NB-based models are quite simple and extremely useful when working with very large datasets. With its simplicity, the NB is able to surpass even some complex classification algorithms.
And will this thing be able to predict better than neural networks?
In some cases it works better even, and in all cases it works faster.
Mathematical introduction of the NBA.
So, let's dive into details. Let's set the task first. Let's rewrite Bayes' theorem in more familiar form. That's better. Let's say we have a column of y classes and discrete x values.
Let's write our x as columns. And now let's make assumption that those signs are independent. Now we can get the values for each the parameters. Just take the data and subtitle it into equation. For all combination of this parameter, the denominator does not change. It remains static. So it can be discredited by introduction proportionality into the equation. In our case, a class variable y has only two results, yes or no, and there are cases when the classification can be multidimensional. Therefore, we need to find a variable of class y with maximum probability. If this class and the attribute value never occurs together in the training sample, then the probability estimate based on frequency will be 0, since the probability estimate is directly proportional to the number of occurrences of the attribute value. This is problematic because it will destroy all information in the other probabilities when they are multiplied. Therefore, it is often desirable to include a correction for a small sample in all probability estimates, so that no probability is ever set to 0. This method of regularization of naive Bayes is called Laplace smoothing. Remember that is written. Another way to work around this problem will be present later, when we get to analyze the article. What should I do if the signs from x take continuous values? A simple way would be to divide our features into intervals and instead of value xe, say which interval our feature belongs to. But because of this, a sampling error appears. We will be smarter. We will use the Gaussian NBA. We will make a strong assumption about not normality of the distribution of features. When for each features xe, we'll be find the mean and variance for each class y. Then the probability density v of given class can be calculated as follows. A simple example of the Naïve Bayes classification.
To analyze the method, let's take the most popular dataset for classification, Fisher's irises. I'll tell you what this dataset is about. Fisher's irises consist of data on 150 specimens of iris. 50 specimens, each from three species: Iris setosa, Iris virginia, and Iris versicolor. 4 characteristics in centimeters were measured for each instance:
Sepal length, sepal width, petal length, petal width. Here you can see how the parameters of the iris are distributed among themselves. As you can see, some parameters can be clustered. Let's see how Naïve Bayes can handle this. To do this, run my code. As a result, when checking, it turned out that we were able to predict the iris variety with an accuracy of 92%, which is a good result, given that parameters for the most part are not normally distributed. Paper Naïve Bayes for text classification with unbalanced classes.
Now we have reached the article itself. The article is called Naïve Bayes for Text Classification with Unbalanced Classes. In article, the authors from New Zealand used multinomial Naïve Bayes. This is the same method, but for working with text, where frequency of the word and commentator is taken as a sign. The Naïve Bayes does show itself best when working with text. At the pre-preparation step, we pay attention to prepositions, service words, suffixes, and other stop words. Then, the document is divided into a collection of words. The order doesn't matter. The probability value of class C in this test document D is set as follows, where n omega d is the number of times when the word omega in the document D. P omega c is the probability of observing of the word omega for given class C, and P d is a normalization constant. At last time we are not much interested in. PC a priori probability, which is estimates from the training documents. As before, let's define the probability P omega c, assuming that the probabilities of meeting each words are independent, where DC is a collection of all documents with C. In formula, the problem of zero probability is taken into account, which is why we see 1 in the numerator and k in the denominator, the size of the dictionary. This is the also called Laplace correction. Remember it? Many text categorization problems are unbalanced. This can cause problem because of the Laplace correction used in P omega c. Consider a word omega in two-class problem with class C1 and C2, where omega is completely irrelevant to the classification, like a stop word. This means the odds ratio for that particular word should be 1, so that this word does not influence to the class probability. Assume the word occurs with equal relevance frequency 0.1 in text for each of the two classes. Assume there are 20,000 words in the vocabulary, and the total size of corpus is 100,000 words. Figure 1 shows the estimated odd ratio based on P omega c as the relative size of the two classes changes. It has the desired value of 1 when the both classes contain the same number of words. However, the situation changes dramatically as the class size become unbalanced. For example, when C2 becomes very small and consists little text relative to the other class, the presence of the irrelevant word omega in a test document substantially increases the estimate probability that the test document belongs to class C1. Fortunately, it turns out that there is a simple remedy. We can normalize the word counts in each class so that the total size of classes is the same for both classes after normalization. To do this, we replace n omega d in this. We normalize the vector of words counts for each class to have length alpha after measured according to L1 form. This assures that the estimated odds ratio for our irrelevant word will be 1, regardless of which particular value we choose for normalization constant alpha. The value of alpha determines the amount of smoothing across the word counts in the dictionary.
Application of multinomial naive Bayes in practice.
Well, Bob, it's certainly cool that you read the article, but what's the point if you don't use the knowledge?
Ramil, I thought so too, so let's try to apply the new knowledge on the example of filtering questions on the Quora platform. Quora is a platform that gives people the opportunities to learn from each other. Here you can ask questions, communicate, exchange unique expressions, and get qualified answers. The main task is to beat out the fake question that is so then not related to essence of particular problem and are made under some false pretext with the intention to declare themselves, or just to advertise and not found a useful answer. Just that examples of good questions. And that examples of bad questions. The first thing I did was reprocessing the text question. I have reduced all words to lowercase, removed all punctuation marks, and made lemmatization. Lemmatization is a reduction of words to their initial form, as if we wanted to write them into a dictionary. As an example, this is how we transform the first expression.
As you can see, the language model did not cope with lemmatization. The word nationalist remained in the plural. But even so, we will see in future the result will be good.
Ideally, it would be possible to remove stop words, prepositions, service words, article, pronouns, and other words that do not help to classify the text. But you don't need to do this because the approach we use, multinomial naive Bayes adjusted for alpha, can correctly assign the probabilities to these words. But my recommendation would be to delete this word to reduce dimension of the dictionary and reduce processing time. But in the implementation, I did not delete the stop words because of possibility to remove important word to analysis.
Experiments has shown that the anagram approach provided to be effective. This is filling the dictionary with combination of n words. That is, we are already beginning to count the probability of belonging to a class for combination of words. I use the bigram model. It showed a better result than monogram model. But with future experiments you can find a more appropriate number of words. During the checks, it turned out that the most suitable alpha was equal to 10. As a result, multinomial naive Bayes showed a good result with my corrections. On the training model, the average prediction was 93%, and for the test sample, as the result was 94%. And it's so cool. Conclusion. The naive Bayes method is a simple classification model with which you can quickly make prediction. Its training is fast compared to other model, so it can be used in real time maybe. Although there are quite strong assumptions in it, as we have seen, it scopes well with text analysis. For me personally, it was my first experience with natural language processing. I'm very glad that I was able to get so much good results and got my first experience with the text. This video was recorded in 3 weeks. I processed the audio a lot, but I hope you liked everything.
I don't think that the English homework would drag me out so much.